This video is about inverse secant, cosecant, and cotangent functions. And so we've already learned about inverse cosine, inverse sine, and inverse tangent. And we found out that they are functions. They pass the vertical line test. And in order to have an inverse function for sine and cosine and tangent, we found out that we had to restrict their domain. That is also the case with cosecant, secant, and cotangent functions. And so let's begin by recalling sine and cosine functions. Okay, so for the sine function right here, the inverse sine function, it's the output of the inverse sine function is going to be either in quadrant 1 or quadrant 4, and it's defined in such a way that we go from negative pi over 2 to pi over 2. This is the output for the sine function. So I've put the unit circle here just as a reminder to help us through this section. So we know that the inverse sine is going to be between here and here, either quadrant 1 or quadrant 4. And then we also learned that the tangent function was that way. The inverse tangent function was, the output would be not including negative pi over 2 and pi over 2 because it's undefined there, but as close as you can get to that. So that's what its output y is. So if you look at the way what I've listed these functions over here, I've got the x's right here, which is the input or the domain is listed right here. Here's the function right here. The x values are the domain, and then the y values are the range. So this is how I've sort of organized this. So I'm going to draw a line through the ands. And so the range of inverse sine is between negative pi over 2 and pi over 2, which is quadrant 4 and 1. The range of the inverse tangent is between negative pi over 2 and pi over 2, which is between 4 and 1, not including the endpoints. And then the other one, the new one we're going to learn today, is cosecant. And it's got the same range, and this is where y cannot equal to 0, because it's undefined there as well. But we will just put this right here. I'm going to highlight this in pink because it's the same two quadrants we're always going to for cosine inverse as well. So we have tangent inverse and the cosecant inverse are all pulling from quadrant 1 or quadrant 4 when we're taking its inverse. So I'm just going to highlight these guys this way. Now that's pretty easy to remember for me because cosecant makes me think of sine because it's defined to be 1 over sine. So that is with that. Tangent makes me think of sine because sine's in the numerator. So that one helps me with that. Let's look at the other ones real quick. We have cosine inverse, right? We learned about the cosine inverse, and the cosine inverse, we're going to pull its range values are between 0 and pi. So 0 is here, pi over 2 is here, pi is here. So this is going to be between quadrants 1 and 2 is where we're going to get the cosine inverse function. Similar to cosine inverse is secant. That's easy to remember because secant is 1 over cosine. So the secant inverse, its output will also be between quadrant 1 and 2. And cotangent inverse is similar in that way. We're going to pull his output between quadrants 1 and 2. And I remember this one because cotangent is defined to be cosine over sine. So cosine's in the numerator. It's going to go with the cosine values. So I'm just going to highlight these guys right here in yellow. I'll do them in yellow. So for cosine inverse, secant inverse, cotangent inverse, their outputs are between quadrant 1 and 2. All right. So what, let me just highlight these guys. This is for cosine inverse, secant inverse, cotangent inverse. This is its domain. And this is its range. Okay. All right, for these functions. You can also see a picture of what these functions look like. There's some really good ones in the book. So they are functions. They do pass the vertical line test. And so you can graph them as well. Mostly what we're going to do with these inverse functions is look at them algebraically. And right in this video, we're getting used to what these are. And then we begin to see why we're using them. Because when we use them, we're going to use them to solve trig equations. So that's what we're building up to. So this is the function itself, the domain, and the range. Okay. These are some identities right here for this. And so if we're given the inverse secant of something and we want to say what is the value of x, this is equivalent to the inverse cosine, which we're already familiar with, of 1 over x. And so these are the same domain on the x. So the cosecant inverse of something is equal to the inverse sine of 1 over that something. For cotangent, it's the same, the inverse tangent of 1 over that. However, because the tangent inverse is defined between quadrants 1 and 4, but the cotangent is defined between quadrants 1 and 2, when we take this inverse tangent, if the value of x is negative, we have to add pi to that to get it in the right category. Now, the reason we're being strict about this is because that's how these inverse functions are defined. That's how a group of mathematicians got together and said, how should we define these guys? What value should we decide they are? Because the truth is there's an infinite amount of angles that would give you these values, okay? So which one should we decide so we can speak the same language? They decided that they would define cotangent, secant, cosine inverse between 1 and 2, and sine, tangent, cosecant inverse between 1 and 4. So that's just a decision, mathematical decision that was made. Okay, so let's do this first part, and then we'll take a break, and we're going to transition into how to find these answers as if we were at the end of solving an equation, because that's what we're stepping ourselves into. So right here, it says find the exact value of x in radians. So this is the second thing I'm introducing to you is the book is starting to do this, and many people use this convention where if they use an x, the answer will be in radians, and if they use theta, the answer they want it in degrees, okay? And so these are without using a calculator, and when they say something like exact value or without a calculator, either one or both in this case, we're going to be using unit circle value. So however you fill out your unit circle, whether you're using special triangles or reference triangles, or you've just kind of figured out how to memorize all these, either way is fine. But have your unit circle handy when we go through these. All right, let's just begin. The second thing that's the same here as was this, like for sine, cosine, tangent, inverse, is that this arc, ARC means inverse. So arc cosecant of negative square root of 2, for instance, is equivalent to the inverse cosecant of negative square root of 2. So that's what arc means, the same thing as it did before. All right, let's do 1 through 8. Number 1, it says x is equal to the inverse secant of negative 1. So look at secant, inverse secant. This is equivalent to the cosine inverse of 1 over whatever this value is right here. So this is equal to the cosine inverse of 1 over, in this case, negative 1, or the inverse cosine of negative 1. So how you find this value of x is you ask yourself, you would take the cosine of both sides and you ask yourself, what angle has a cosine of negative 1? So where is cosine inverse defined? Between 1 and 4. Between quadrant 1 and quadrant 4, what angle can you take the cosine of and you'll get negative 1? And the only one is pi. This is negative 1, 0, right? And the cosine is the x value. So the answer to this is pi. This is how it goes. All right. How about the arc cosecant of negative square root of 2? This is equivalent to the sine inverse of 1 over negative square root of 2. So you ask yourself, what angle has a sine value of negative 1 over the square root of 2? And you're like, well, the sine is negative. It's not in quadrant 1. It's got to be in quadrant 4 because this is the 2 I get to choose from sine inverse. This is where it's negative. So what angle would have a sine of negative 1 over the square root of 2? That's the 45s. It's this one. Negative 1 over the square root of 2 is the sine. And the cosine is positive 1 over the square root of 2 in quadrant 4. All right, so it's this angle right here. But when they're being very strict about using inverse cosines, technically speaking, this would be negative. We would think of this as negative pi over 4 because it's defined in terms of negative pi over 2. Okay, so that's how we have to call that out. Cotangent inverse. All right, this is equivalent to the tangent inverse of 1 over the square root of negative the square root of 3. Okay, how I think of tangents is I imagine these are over 2. That's the same thing because then I see values on my unit circle. Tangent is sine over cosine. All right, where can we pull from tangent? Quadrant 1 or quadrant 4? If tangent is negative, we're in quadrant 4. Where in quadrant 4 is the sine 1/2 and the cosine square root of 3 over 2? So the cosine is square root of 3 over 2 here. And the sine is negative 1/2. So this is the angle we'd be talking about right here. Again, tangent is defined in terms of negative pi over 2 to pi over 2. So we would go down here and we would call this negative pi over 6 is going to be our answer right there. All right, the tangent inverse of square root of 3. Okay, I think of this as square root of 3 over 1. And I put this over 2 and this over 2, which is legal. Because I've basically multiplied by 1/2 in the numerator and the denominator. So I'm saying what angle has a tangent of positive square root of 3 over 2, 1 over square root of 2. I mean, sorry. Square root of 3 over 2 over 1/2. In other words, where's the sine square root of 3 over 2 and the cosine 1/2? Because that's how tangent's defined. Well, it's positive, so should I pull from quadrant 1 or quadrant 4? Well, tangent's positive in quadrant 1. I need to pull from here. Where is the sine square root of 3 over 2 and the cosine 1/2? That is this angle right here. This is 1/2, and this is square root of 3 over 2. And what is this angle? This is pi over 3. All right, so that's how you go about figuring those out. Oh, I have to come back to number 3. There's a little mistake here. This is the cotangent one. This is kind of the tricky one. Tricky, Ricky. Okay. Although the tangent inverse of this is negative pi over 6, because cotangent is what we started with, and it's defined in terms of quadrant 1 and 2, then the rule here is if x is negative, and it was, then we add pi to that at the end. So although that's true, because of how this is defined, in a minute we get to leave how it's defined and just figure out the right angles. But because cotangent is defined between these set of angles, we have to add pi to this. And this is 5 pi over 6. And so this is going to be the most correct answer for that one. Okay. So let's see here. Let's jump over here to these. And the difference in 5, 6, 7, and 8 is that they ask for theta. And that means we're starting to realize that this is where they transition. Theta is in degrees. So let's call these guys out. The inverse cosine of negative 1 over square root of 2. All right, is cosine negative in quadrant 1 or quadrant 2? In quadrant 2. Where in quadrant 2 is the cosine negative 1 over the square root of 2? It's right here. It's this 45. And so this is negative 1 over the square root of 2, 1 over the square root of 2. And in degrees, this is 135 degrees. So this is going to be 135 degrees. That's the answer to that one. How about the arc cotangent of -1 over the square root of 3? Okay, here we are. We're at this guy again, and x is also negative again, so it says to add pi, but since we're in degrees, we're going to add 180. Okay, we got to remember, add 180. All right, so this is equal to the tangent inverse of 1 over the value that we're taking up. So 1 over that is just its reciprocal. So we're looking for somewhere where the tangent is negative square root of 3 over 1. And I like to say these are over 2. So if I go to the tangent inverse, tangent is negative here. Where is the sine? Negative square root of 3 over 2. And the cosine is 1/2. That is down here. This is this value. This is 1/2. And this is negative square root of 3 over 2. And this is in degrees, or in tangent, this would be negative pi over 3, okay. But I'm supposed to add pi to that, so negative pi over 3, which is what I was saying, 180. I'm going to do it in radians. Plus pi gives me 2 pi over 3. So that's my answer. 2 pi over 3 is right here, so that is in degrees, that is 210 degrees. I know that's a bit confusing, but you get used to it as you do more. I'm going to come back to number 7. Let's do 8. This is equivalent to the sine inverse of 1/2. Of 1 over 1/2. No, I didn't mean to skip number 7. I'm sorry, let's do 7. This is equivalent to this. This is the secant inverse of 2, which is equivalent to the cosine inverse of 1 over 2. So cosine is positive in quadrant 1 or quadrant 2? In quadrant 1. Where's the cosine 1/2? It's this angle right here, which is pi over 3, but it's in degrees, so that one would be 60 degrees is the answer to this. Okay, number 8. The inverse cosecant of 1/2 is equivalent to the sine inverse of its reciprocal 2. And if you put that in your calculator or try to find it on the unit circle, you will not find it because this is outside the domain, the range of sine. Sine only goes between -1 and 1. And so this does not exist. Okay, so let me just double check real quick to make sure I am agreeing. I put does not exist. I also put undefined. Either one of those would do. 610. I said 210. Let me see if I'm disagreeing with myself here. Let me check this out. I said 2 pi over 3. This is 90 plus 30. Yeah, this is wrong. This is not 210. This is 120. I apologize. This is 120 degrees. Okay, good. Okay, that is 135 pi over 3. 5 pi over 6 is what it ended up being after we added the technically correct. Negative pi over 4 and pi. Okay, that's all right. I'm going to take a break, and then we're going to do the last, which is starting to transition us into solving trig equations.